Hi everyone, this is Alexis from SenseFly. Welcome to our new webinar. Today I'm going to present you all the new features in eMotion2 and in Postlight Terra3D3. Before starting, I want you to make sure that you all updated your software to the latest version. So the latest version of eMotion2 is the version 2.3.0. and the latest one of Postlight Terra3D3 is the 3.1.40. One of the main new features is the new camera. The new cameras, eMotion now support all our new cameras. So to see all the new cameras, please go to the Mission Planning tab, and in the Camera Model section you can select the right camera before flying. So here are all the new cameras: the S110 RGB, the S110 NIR, which is the default camera in the eMAG, the S110 Red Edge, and our new multispectral camera, the Multispec 4C. It's pretty important to select the right camera model before flying because it's going to change the flight altitude for the same ground resolution. So let's imagine that we fly with a ground resolution of 4 centimeters, and we can see that with the Ixus camera the desired altitude is 130 meters. And if we change the camera for the S110 NIR for the same ground resolution of 4 centimeters, we can see that the desired altitude is 114.5 meters. eMotion also supports now the raw images, especially for the S110 cameras. Before going through the Flight Data Manager and showing you how to pre-process these raw images in order to get TIFF files to make the processing in Postlight Terra3D, let me show you two examples of JPEG files and RAW files. RAW means that the image is basically in the original state as covered by the camera sensor. But in that case, JPEG images are processed right within the camera, based on your camera settings. That is, for example, adding contrast, brightness, noise reduction, sharpening, and others. Afterwards, it is compressed into JPEG format, which is optimal for visualization. JPEG is sufficient for most use cases in standard aerial imagery, but it is not suitable for index calculations like NDVI and others. On the other hand, raw files are larger, look dark, flat, and lack contrast, but contain much more information and are intended for professional post-processing. Let's get back to eMotion, to the Flight Data Manager, to pre-process our raw files. It's important to pre-process your raw images through the Flight Data Manager, as eMotion performs band arithmetics on each image. It's now mandatory to use the Flight Data Manager to geotag images. Today we're going to geotag flights which was monitored by another computer. It means that all the images and the BBX file have already been saved on my laptop. So I just have to write my flight name, webinar 1, and I click next. Here I have to browse to find the right BBX file. So here it is, and I click next to copy the log file to the project directory. Here's the next step. That's one of the new steps, when you can select first the images from a specific folder. So let me select the right folder with all my images. But the new thing is, here you can tell which camera you used for the flights. So in that case, you can either select no raw files, means that if you if you're using the, for example, the XS camera, or if you're using the S110 with RAW file, you can select the right camera. So here, for this slide, I use the S110 NIR camera. I just click next. The Flight Data Manager has now matched the images, and I can click next to copy and pre-process these images to convert these raw files into TIFF files in order to be processable into Terra3D. Okay, now we ready to create our post-flight Terra3D project and geotag the images. Just click next, and we can directly open our post-flight Terra project through the Flight Data Manager. So it's pretty important to geotag our images through the Flight Data Manager for two reasons. The first one is in order to pre-process the images, and the second one is to have the right band orders, especially when we want to calculate custom formula in the index calculator in Terra3D. I'm now opening my project post-flight Terra3D. Before starting to talk about the new index calculator and the agriculture function, I want to show you all the improvements here and there in the new version of post-flight Terra3D. The first one is the online help. It's more complete, as we have now more than 200 articles, so most of your questions have the answer in this knowledge base. The second improvement I wanted to show you is the rematch and optimize button. This function can be used for a project with a lot of images that haven't been calibrated. I mean, after the first step, if you realize that in your post-flight in your quality report a lot of images haven't been taken into account, you can add manual type points in the point cloud and then rematch and optimize. At the end of the rematch and optimize, you don't get a new quality report. If you want to get so, you can click process and generate quality report. This new option as well permits people to generate quality report at any time, new quality report at any time. So if you do any change in the point cloud and you reprocess the first step, then you can get a new quality report. The other main change regarding the images is the tolerance. If you look at the image properties editor, there is now two new columns, which are the horizontal tolerance and the vertical tolerance. We added these two columns to especially for our new eBRTK. These two columns mean the precision of the geotag on each image. So in this example, the precision, the tolerance, the horizontal tolerance of this image is 6.3 meters and the vertical tolerance is 5.4. In the case of the eBRTK, there will be much lower values. Last thing before starting to talk about the index calculator is the point cloud densification area. As you already know, you can define a point cloud densification area, and you can now design this area in 3D in the Ray Cloud editor. To create such an area, you can click right on processing areas and new point cloud densification area. I've already set a new point cloud densification area, and you can see here that there is now a red box. If you want to change this area, just click on the vertex and you can extend the size of this area. And now we can see the result of my new point cloud. If you want to get this new area as an output, you have to reprocess the second step. So it's only displayed on the fly in Postlight Terra3D, but if you want to really get it as an output, you have to reprocess the second step. Let's see now our new index calculator. To access to the new index calculator, you have to first process the two first steps, and then you can directly go to index calculator. So in my case, I have already generated my color index mosaic, but we're going to see today all the different steps in the index calculator. So the index calculator sidebar is made of three parts: the reflectance maps part, the index mosaic, and the colored index mosaic. When you access to the index calculator, there is no map displayed in the middle, so you have to first generate your reflectance map. To do so, you have to define the resolution and click generate. It's mandatory to go through this step, and you're going to get, at the end of this step, you're going to get the bands of your camera. So in my case, this is our NIR S110 NIR camera, the red band, the green band, and the NIR camera. And Postlight Terra3D displays some statistics about the different bands. At the end of this step, you don't, as I already said, you don't have any maps displayed. You have to go to the index mosaic to generate your own index mosaic. So in our case, I have already generated the NDVI map by selecting NDVI map and then clicking generate. Here is the formula of the NDVI, NIR band minus red band divided by NIR band plus red band. People can use their own formula by creating their formula in the new index list. So I click index list. By default, I do have some formulas. For example, just the red band, green band, NIR band, grayscale, and NDVI. Then you can create, by clicking add a new index, you can create your own formula. So for example, let's say red plus green, and OK. I'm going to name my new formula red plus green, and OK. So here's my new formula, red plus green, and I just have to generate it to have this map displayed in the main part. Once this map is generated, I can at any time go back to all the mosaic already generated. So for example, NDVI map, red-green map. Once it is generated, I can see here that there is some statistic displayed regarding my band. The third and last step is about the colored index map. This step allows the user to assign a color to a given index value in order to visualize a colored index mosaic. So the x-axis represents the index value, in our case the NDVI value, and the y-axis allows the user to define which color is assigned to a given index value. The histogram is divided into 50 bins, and when hovering over a bin, the percentage of pixels belonging to that bin range and the minimum and maximum values of the bin range are displayed. So in that case, 6.6% of the pixels are in this bin between 0.56 and 0.60. By default, two anchors are displayed, two anchors that you can only drag vertically. Each anchor allows the user to select the color that will be assigned to a given index value by dragging it vertically. Let me show you again. You can select which color you want. You can create as well new anchors by right-clicking in the histogram and add anchor. By create a new anchor, you can see the different, you can change the display of your map. So for example, in that case, all the pixel values between minus 0.98 and 0.12 will have a color between the red and the yellow, and all the pixels with a value between 0.12 and 1 will have the colors between the green and the purple. If you want to make it clearer, you can create color classes, and just one color will be displayed per classes. So in that case, all the pixels between -1 and 0 will be red, and all the pixels between 0 and 1 will be yellow. Let me change the color, and this way we can see well the colors. You can obviously create add as many anchors as you want by right-clicking add anchor. So in my case, I'm having 3 different classes, one between -1 and 0.62, one between 0.62 and 0.80, and one between 0.80 and 1. So this way you can display the different zones on your map. You can do the same job in grayscale by using the gray gradient and the gray classes. The last button can be used to reset your color mapping, and this way you can restart to create new anchors. At the end, don't forget to save your color map by clicking generate. Generating this color map gives you a GeoTIFF that can be found in the result folder, in the fourth folder named for index and mosaic, and here you get the colored mosaic. Now let's move on to the next and last post-flight Terra3D new features. People can now produce contour lines through post-flight Terra3D. To do so, you have to first select the right file format for your contour lines. So in processing options, DSM and orthomosaic generation, and contour lines. In my case, I decided to go with shape files, but can be also PDF files or DXF file. Then the user have to set the right elevation interval, so in my case 10 meters. Click OK, then generate contour lines. The result will be in DSM, free DSM Orlo, extra, and contours. I've already opened ArcGIS, ArcScene, in order to show you the result of the contour lines. So let's get back to post-flight Terra3D just to show you the point cloud here and the contour line associated to my point cloud. Well, we are done with this webinar. Thank you all for watching. We will have a question session in the upcoming weeks. So please send me an email if you have some questions, and I'll be glad to answer you. Thank you very much for watching, and have a good day. Bye bye.